Let's take a look at some problem-solving application problems. So question 1 says Britt has $2.25 in nickels and dimes. If she has 40 coins in total, how many of each coin does she have? Right now we don't know how to solve this algebraically, so we're just going to create tables to help us look at our data and break things down a little bit better here. So let's just do a column for nickels and one for dimes. Oopsie. My computer is a little bit slow, so I apologize. And I'm going to do a final column for the total here. All right, so I'm just going to start with 20 nickels and 20 dimes and see how much that brings us to. So 20 nickels, so 20 times 0.05 is, well, that's $1, and 20 dimes is $2, so that's $3 total, which is way too much because we only want $2.25. So I'm going to raise the nickels and lower the dimes. So let's just try 30 nickels and 10 dimes. So 30 nickels is $1.50. 10 dimes is $1. So that gives me $2.50, which is still a little bit too much, but we're getting closer to our $2.25. So let's go ahead and test out 35 nickels, and that would mean only 5 dimes. So that would be $1.75 in nickels and 50 cents in dimes, and that brings us to $2.25. And that is what we were looking for. So we need 35 nickels and 5 dimes. And I'm going to go ahead and just write that on the board here. All right, so that would be our answer for this first problem. Looking at the next one, again, I'm going to create a chart to help us out. A pattern of squares is put together as shown. How many squares are in the 12th diagram? Well, in the first diagram, I have 1 square. In the second diagram, I have 3 squares. In the third diagram, I have 5. So you can see that it keeps increasing by 2 each time. So in the fourth diagram, I'd have 7. Fifth one, I'd have 9. So I'm just going to keep going up here until I get to my 12th diagram. All right, almost there. So in the 12th diagram, I have 23 squares. So I'm going to go ahead and just write 23 squares here. All right, let's go ahead and take a look at the next one. It says a restaurant hosts children's birthday parties for a cost of $120 for the first 6 children, which includes the birthday child. So the birthday child is Jaden. So it's going to be Jaden and 5 friends. That is included for $120. All right. For $30 for each additional child. So if he wants to bring a 6th friend, so in addition to his 5 already, that's $30 more, so that puts him at $150. If he wants 7 friends, that would put them at $180. If he wants 8 friends, that would put them at $210, which is too much because they only have $200 to spend. So Jaden can invite 7 friends to his birthday. All right, let's go ahead and take a look at the next one. Oswald is trying to cut down on drinking coffee. His goal is to cut down to 6 cups per week. If he starts with 24 cups the first week, so he's drinking 24, and the second week he can cut down to 21, the third week he can cut down to 18, and notice that he's cutting out 3 cups each time, so he's subtracting 3. So if we keep with that pattern, let's keep subtracting 3. So that'd give us 9. And finally, we're at our 6 cups of coffee. So it would take him 7 weeks to reach his goal of 6 cups of coffee a week. Jessamine takes out a $150 loan from an agency that charges 12% of the original loan amount in interest each week. So what that means is in week 1, we have $150 plus 12% of that we have to pay back. So 12% is 0.12 as a decimal. So the interest alone, there's a 150 times 0.12, that's $18. Okay, so they're paying $18 in interest a week. If we have to do this for 5 weeks, because the interest stays the same, it's going to always be applied to the 150. So 18 times 5 is 90. So we got to pay $90 back in interest. So 150 plus 90 gives me $240. So she's got to pay back $240 at the end of 5 weeks. All right, let's go ahead and take a look at the next question here. Grace starts biking at 12 miles per hour. 1 hour later, Dan starts biking at 15 miles per hour. So I'm going to do a column for Grace and the distance she's gone. And I'm going to do the same thing for Dan. So I'm going to do a column for Dan and his distance. All right, so Grace can do 12 miles in an hour. So that means in 2 hours, she's gone 24 miles. And 3 hours, she's gone 36 miles. And 4 hours, she's gone 48 miles. And for Dan, he's gone 15 miles, and then 30 miles, and then 45 miles. And notice that right here already, he surpassed Grace. Actually, one above that already. So he's gone 30 miles while she's only gone 24. So between his second and third hour, he will catch up to Grace. So between 2 to 3 hours of biking, he will meet Grace. All right. Lemuel wants to enclose a rectangular plot of land with a fence. So the first thing I'm going to do is I'm going to just draw a picture. So there's a rectangular plot of land here with the fence that's going to go around it. He has 24 feet of fencing. What's the largest possible area he could have? So I'm going to do, again, another chart. So length, width, and then the area as well. So let's just assume that the width here is going to be 1. And remember, he's got them on both sides, right? So 24 minus 2 is 22. Divide by 2, that would make the width of this 11, because we want the entire perimeter to equal 24. So if the length is 11 and the width is 1, that gives us an area of 11 feet squared. Okay, well, what if we increase that? Now let's say instead of 1, we have 2. Well, 2 and 2 is 4, so that makes the width 10. And that would make the area 20. So that is larger, but let's keep going. What if I make the width 3? So now this is 3, 3. This would have to become 9 in order for that perimeter to be 24. And you can see a pattern coming here with my length. So 9 times 3 is 27. What about 4 and 8? Because that can be another combination. 4 and 8 is 32. So that's larger still. About 5 and 7, that's 35. And the last combination is possible is 6 by 6, and that's actually a square. 6 by 6 is 36 feet squared, and out of all the combinations, that is the largest one. So he's going to have to make his rectangular plot actually a square plot and do 6 feet for the width and 6 feet for the length. All right, let's take a look here. Tickets to an event go on sale for $20 6 weeks before. So let's make a table again to help us organize our information. So we'll do the weeks before and the price of the ticket. 5 weeks, they go up by $5 each week. So 5 weeks before, the price is going to be $25. Then it's going to raise to $30. Then $35. Then $40. And finally, 1 week before, we have $45 a ticket. So 1 week before the concert, the tickets are $45 each. All right, the last problem we're going to look at here, it says in a one-on-one basketball game, Jane scores 1.5 times as many points as Russell. If the two together scored 10 points, how many points did Jane score? All right, so I'm going to make a column for Russell and Jane and then their total. All right. Now, it doesn't make sense if they both score 0, right? So I'm just going to start, well, if Russell scores 1 point, 1.5 as many times as that is 1.5. So that gives me a total of 2.5 points, which is nowhere near what we're looking for. So I'm going to up it 1. So if Russell scores 2 points, 1.5 times that is actually 3 points. So that gives them a total of 5. Well, 5 is half as many as 10. So if I want to double that, let's just try doubling the points that they scored. So 4 and 6, because 6 is 1.5 times as many as 4. And that gives us our 10 points. So Jane, she scored 6 points in their game.